Any question? So, you know, we have to be patient to get these definitions and description to go on. As soon as we get the data, then our job would be start by, you know, organizing it. So how are we going to identify these when it's going to be given to you? The first one is a random sampling. Okay, so I'm going to give a brief description of each one of them. You know, you get more, you know, if you want in your book, but it's the first one, the best one, random sampling. You see, in the case of random sampling, suppose I want to pick, let's say 15 students out of this class. So if you want to do it randomly, I have to apply a random method, if you like. The random method in statistics, they usually use something that we call it random numbers. I'm going to explain it. And sometimes they use computer to do it. Okay, so in this case, basically the way we are going to do it, subjects or people. Okay, that's the key. Subjects are selected by a device, okay, a random device. It's going to be selected by a random device. That random device, they call it random numbers. Okay, random numbers or a computer. A computer. Okay, this is a good method because what you do in this method, you are going to give everybody a chance. So in this method, each member, okay, each member of the population, for example, of this class, each member of the population has an equal chance. So you got everybody, you know, the opportunity. Equal chance of being in your sample, of being selected. Okay, so we call it random sampling. When they want to give you a statement to identify it, in that statement they say, oh, I select 15 students out of this class by using a random number table. So you say, oh, this is random sampling. The way you get the letter to serve in a jury. Jury selection is randomly. The way they do it, they usually, I think they go with your driver license number. They put those driver license as a random number table, and then they pick you, you know, to come. The way they do it, you know, when it was a face-to-face, we used to, you know, to operate, right? Just give an idea to know what's going on. You see, your random number table is something like this one. You see, you know, you can easily generate a random number table from your calculator or from your computer. So you are going to have this table. This is going to be your random table. So if you want, for example, I would like to pick 15 students. 15 students randomly. I have the roster, okay. So what I can do is, if you want to use this random number table, you have to close your eyes. Okay, you close your eyes and just pick one of these numbers. Okay, you just randomly, you know, randomly you pick this one. So in the one that I have here, so I pick this as a first number. Okay, first number. So it depends how many people is going to be in your class. In this example, we have 728 students. You know, suppose I just talk about all the people who got a course like calculus, college algebra in this college, and I would like to pick 15 people. So since the total is 3 digits numbers, so what we're going to do is you just, this is your starting point. You pick the first 3 digits. You see the first 3 digits is 69. So the first student that you are going to pick for your sample is the students with the rank 69 on the roster. You go and pick this one, John. Then you go down. The next number is going to be 988. It's no good. because you have only something like 700 students. So you drop this one. Then you go down, the next one is going to be 386. So go to the roster and you pick this students. Okay, just keep going so that you'll be able to pick 15 students. Okay, if you're not going to be done by the bottom of the column, you have to come back. Okay, you come back and you continue. So you go back somewhere. So you already got two digits left. So you pick another digits and continue. Okay, it's a random device. The method you pick it yourself. This is just a suggestion. Okay, so you need a kind of a random number, generated random number table, and they are not going to be unique. Any computer would give you one. So that's the idea of the random number. But today, you let the computer to pick those numbers for you. So when they say random numbers, this is what they mean, a random number. You can check it. Any question? So if you use this type of device or any other random device and pick your subjects for your collection, so you're just using random sampling. Okay, it's easy method to do. Okay, and you can claim that, yes, it is. It's a random one. So you gave everybody the chance to be in your collection. Okay, any question? So the key for the problems is this term, using random number or a computer. If you see this one, you say, oh, this is a random sampling. Okay, that's the first one. Next one. This next one is also easy to operate, may not be a good one. Systematic. Okay, this is going to be systematic sampling. See? In case of a systematic sampling, so again, you want to pick 15 students out of this class, okay? 15 students of this class. So what you're going to do, you go around the class and you pick the first person. So I pick you at the first one. Then I pick every, different. Then I go and pick every second person, every third, every fourth, every fifth. Okay, depends. So in the systematic sampling, you're starting from, you pick somebody randomly, I pick you randomly. Then I pick, every second, see, you are in 1, 2, you are in 1, 2, you are in 1, 2, 1, 2, 1, 2, 1, 2. So we start from somebody in the sample, and then we pick every second, every third, every fifth, every sixth. So it's very easy to identify because they are going to tell you. Okay, and it can be mathematically done. So this is called systematic. So this is it, subjects. Okay, in this case, subjects are selected by using, by using every depends, every second, every third, every fifth, say every kth. Okay, you decide what is going to be the k. Every kth number. Okay, number, of course, after selecting the first one. After the first, okay, after first subject. First subject is what? Is selected. Selected randomly. So this is called a random sampling. Okay, the random sampling, you pick the first one. So again, I can show you. You are not going to do it for us, of course, but suppose in future you would like to do it. So on the test, on the problems, very easy to identify. You look for this number. You see, as soon as they say every fifth, every second, every third, systematic. Just to show you how you can do it. You see again, We are not going to give you bad. It's not bad to know it. Suppose we want to let's say find a sample. Okay, suppose you want to find a sample. Okay, find a sample of 15 students. Okay, 15 students out of 728. Okay, students enrolled. Okay, enrolled in, let's say, in the college algebra. In college algebra. Okay, at Palmer College, PCC. Suppose you would like to do it, I just show you how to do it. Okay, yeah, you have to decide this number every what. Okay, so what you can do over here is we get this range first. You see the number that you like is 15. Okay, if you like, this is going to be a solution. You see the population size. Population size is going to be what? Is 728. Okay, that's going to be a population size. And the sample that you're going to be interested in, okay, let's say the sample size. What is the sample size? The sample size is 15. So in order to find out this K that you're going to use, so you divide 728. Okay, divide 728 divided by 15 here to give you a range that, that's going to be possible to pick these numbers. Okay, so what is 728? 728 divided by 15. You see that gives something like a 48. It's a 48.5, you can call it 48 or 49, doesn't matter. Okay, it's going to be 48.5. You may call it 49. Okay, call it 49. So that gives it the range that you can pick for this K that you have. So what you need to do is you have to pick a number between 1 and 49 for your K. Okay, any number will do it, it doesn't matter. Okay, so select, if you like, you select a number. Select a number between, okay, between 1 and 49 randomly. Okay, you can pick something easy to be able to do it. Okay, so what I do, for example, I pick K equal to the what? K equal to the 20. You can pick any number you like. Okay, so for example, my collection and your collection would be different. So I picked K equal to the 20. So this means what I'm going to do is I go around and I select the first student, then I pick every 20th students to be able to get that 15. Okay, so you pick any numbers, then you go with every every 20 to be able to do it. Okay, so this is going to be what I pick the first one, and then I go with okay. So you can start with you get the first student with the student number 5, and then you can add those numbers that take you to the 15. Okay, so it's going to be number 5. Then the next student is going to be number 25, if you like. Okay, and the next student is going to be what? You add another 20, so that gives you 45. 45, 65. Okay, 65, then 85. Okay, then 85, and then you continue to get this. Okay, it's going to be 105, and then you continue to get the 15 students from this collection. Okay, so what we collect, we select. Okay, select every. Okay, every 20 students for your collection. So as soon as we see this number, that will tell you that it is systematic. Okay, so on the test and on the problems that you have, as soon as you see this expression every 20, every second, every fifth, every sixth, then you realize that this is systematic. Okay, any question? So it's cheap, it saves time. I told you, it depends what you want to do. If you want to justify your result, get a report, get a grant, you claim that you did something scientifically, you just use this type of method. So these two, you can't miss it. And this is just for your information. We are not going to do it practically. That will take us to a very tricky one. This tricky one, number 3, is cluster sampling or clustering method. Cluster sampling. This is the one that is used by government. Okay, because that's easy to operate. What is cluster sampling? You see, we use this one when the population is very large. So what we're going to do, we are going to divide the population into different parts, different zip codes. These zip codes or part, we're going to call it cluster. Okay, so, the population of San Diego. So the population of San Diego are going to be different, they're living in different zip codes. So each zip code is going to be your cluster. Then among the clusters, you randomly pick 1 or 2. Okay, so you want to collect information from the population of San Diego. So you divide the San Diego, you look at the different zip codes that you have, then you pick just 1 or randomly 1 or 2 of these clusters, and then you go inside the cluster and you collect your information. This is the one that we call it clustering. Okay, so in clustering method, you divide the population. We divide the population into different, let me write it down so that we can argue it. You see? So the first step, you divide, in this case, divide the population. Divide the population into groups. These groups are going to be called clusters. Okay, clusters. Then pick some of these clusters random. This is where you claim that you did the random procedure. Obtained. Okay, obtain a random sample. A random sample of those clusters. Random sample of clusters. You may pick 1, 2, 3, but you just do it randomly. Then, of course, you use everybody in this selection, everybody in the clusters to collect your information. You go inside and you interview everybody. So the third part is going to be use. Okay, you're going to use all the members in the clusters. All the members of the cluster, of the clusters obtained. Okay, obtained in in step 2, if you like. Step 2 as the sample. As the sample. This is called clustering method, cluster sampling. What's wrong with this one? I mean, wrong means, what is not going to be fair about this one? Any suggestion? Remember, we have different zip codes of the city, and you just pick some, a couple of them. Any suggestion, any comment?
Is it that you have to like personally divide the population into groups that doesn't make it fair?
Oh, that division is okay. But what is unfair about those clusters that you're going to pick? Remember, your sample must be a very good representative of the society. So if you pick this sample from San Diego, so how are we going to claim that your sample at the end is the representative of everybody that lives, in San Diego area?
Is it how you pick the zip codes as well as the which of the groups you pick in that cluster of zip codes you pick?
Yeah, you see, you know that the people who living in zip codes in one cluster, they are more like each other. I mean, they are going to be more homogeneous, if you like, than the full population of San Diego. So it depends which zip codes are you going to select. Because suppose you want to know whether the people like to, like a swimming pool, like a free swimming pool or something luxury, if you like. So if you pick if you pick a cluster, which is going to be, in a rich area of the San Diego, of course they love it because they are not going to pay for it. So in that case, you didn't get any idea of the other people with different social background that are living in other part of the city. So the difficulty with the clusters are going to be, as I talk about it, the people who live in one cluster are more likely from social background, life, fashion, etc., are more close to each other. So your sample is not going to be very good representative of the full population of the city or the full population that you're going to have. Okay, that's why they say your clusters may be biased, if you like, to get these numbers. But since the government, when they want to collect the information, you see the population is very large. I mean, you think about California, for example. So when they want to carry this type of research, the clustering is easy as well. It's easy, and at the end, when they give you the report, you're not going to tell you that, oh, we use the clustering sampling to get this report. No, they are going to tell you that we did carry out a statistical study of the San Diego, and based on those information, we find out that that's it. The people like a swimming pool without paying any taxes for it. So that's it. That's the way it is. But the only difficulty about the clustering is, you see, your sample must be a representative of everybody in the population. If you pick this sample, that would be a very good one. But the result of the clustering is not a representative of everybody, because you may pick 2 or 3 zip codes, but the people living in different zip codes would have different idea, different social background. Okay, so that's the only disadvantage of this. So I just make a note that, just make sure that you know that this is the only difficulty, is that, note that, that will help you in future when you want to do some statistical study, or if you want to read some sampling reports. So you look into some details. So note that the cluster sampling, as I talked about it saves times. Yes, it saves time and money. So that's good for the government or any institution that they want to carry out. But the difficulty is it doesn't represent everybody. Okay, because you're just talking about clusters. So it does not represent, okay, does not represent everybody of, members. It represent all members, if you like, okay? All members of the population. Okay, so it's good, not bad, but it's not going to be the case. You just collect the information from the people that are homogeneous, the lifestyle, They are very much like each other. So won't give you a good result. So that's clustering. And it's tricky when you want to check it. You will see it, we give an example. So the best way to find out that you select the good one, if we give it a statement, you are going to tell us whether it's clustering or not. You just think out the final result. Is the result representative of everybody in the population or not? That would be clustering. Okay, now, if you want to correct it, you see the correction is going to be the next method. The correction is going to be, you do the clustering. You divide the people into different, cluster or group. But then when you want to obtain this sample, you go inside each cluster. You go inside each cluster and you pick some people out, each cluster. So you go to the first zip code. If it's a very small zip code, the population is 100 people, you may pick one person. But when you go to the next zip codes, you may have 10,000 people. So in that case, you are going to pick 5 people. So at the end of the day, you have one representative of each section of the society. And that would be the best one. It takes a little bit more time and money, but that's best. The name is stratified. So the difference between stratified and the clustering is just the last product, if you like, okay? So that's going to be stratified random sampling. That's the best one. Random sampling. So the division is the same. Okay, you divide the population different. So as we did it for the other one, we are going to divide the population in question into sub-collection, subpopulation. They don't use the term subpopulations. They don't use the term cluster. The term that they use is strata. Stratum for a single one, strata for the plural. Okay, strata. Cluster, stratum over here. Okay, divide the population into sub-collection. Now the difference is here. You see then what we're going to do? You see, look at this one, if you want to compare it with the other. So what you do in this case, you go from each of sub-collection. Each stratum means sub-collection. Clusters. From each. You pick some people out. Obtain a random sample. You pick some people randomly from each zip codes. How many depends of size, depends on the size of the sample. Of size, proportional. Proportional to the size of the zip codes, to the size of the zip code. In this case, a stratum is the expression that they use. Okay, if you have, if you one section, some sub-collection have more people, of course, you are going to pick more representative. It's like election. Then you pick, you have all these representative, you put them together, and that would be your sample. Okay, so you're going to use, all the members. Use all the members obtained. Okay, all the members obtained in the step. Okay, in step 2 as the sample. It's a very good one. If you have all the information, you can easily do it to get, to get these numbers. So this is going to be stratified. So as I told you, these two are going to be tricky. When it's given to you, you want to decide which one is it. Read it carefully to see what's the final result. Are you having a sample that have a representative of everybody from the population? That's the best one, is stratified. But if you pick that just working on the interest group, if you like, that's clustering. You just consider interest of, one zip code. So that would be the case for the stratify. Any question? The easy one, and very much not scientific one, is convenience. Okay, so this means you won't do anything. If you want to collect the information, you go to the library. You go to the library and look at the past newspapers if you like. Or you just collect the information from the member of your family. So this is called convenience. Okay, you are going to pick the easiest method that's possible. Okay, that's going to be convenience sampling. Okay, convenience when you just pick a method which is easy. Use the result. That's already there in the library, newspaper. Use the results that's easy to get. Okay, that are going to be easy to collect, easy to get. Going to the library, asking the family members. Inside your class, you ask your friends, and you just pick the information. Of course, this is not going to be a good one, but it's, it's a lazy one. But scientifically, if you want to make something else out of your sample, you must prove that you do use some random sampling in order to get it. Okay, you have a list of the problems in your book or probably in your math lab. And we give you one question on your next quiz and one question on your next test. We give you 5 statements and you're going to tell us which of those are going to be referring to this one. Random sampling, easy. They have to tell us that, they did it randomly using either a random number table or a computer. Systematic is the easiest one because they have to tell you which those every what? Every second, every fifth, every third. So those two are easy. Clustering and stratify, you have to pay a little bit more attention, to be able to get it. Okay, we have a collection of these problems. We go back to that worksheet. Okay, there is one part of it from your book and the other ones otherwise. Any question? So that's a big one from this section. Make sure you know it. And we are going to use it. So let me share with you that worksheet again. And we have a couple of nice problems on it. So going back to the worksheet number 1. Okay, let me stop this one, going back to that paper. And the idea how we're going to pick. Like, there are a couple of them here. So this is going to be question number 12. Okay, it's going to be question number 12. And then we continue, we have a couple more. So what we would like to do is classify each sample. Okay, we want to classify each sample. Just tell us which one is it. Is it a random, systematic, stratified, or clusters? Okay, so you read it carefully as we talk about it. If they use a random device to do it, it's a random sampling. If there is going to be every 5th, every 2nd, every 10th, systematic. If they divide it into different parts and pick a special clusters only, that's clustering. But if they divide and pick some people from each part of the society, put them together, that's a stratify, the best format. Okay, are you ready? Let's check the first one. Can you see this one? It's all right. So what is going to be the first one about? You see, the first one is in a large, let's see if I can make it a little bit bigger so that we can see it. You see, that's part 1. In a large school district, all teachers from 2 buildings are interviewed to determine whether they believe the students have less homework to do now than in the previous years. In a large school district, all teachers from 2 buildings are interviewed to see if we need to do the homework.
Is it cluster?
It's cluster, yes, you are right. It's cluster. You see, because in a large school district, there are many, many buildings. So what they did, they only picked 2 buildings. So for example, they may pick the building of the science building and natural science, or just science building, and they asked the question. So your result, you see, your result is not going to be a good representative, because how about the other buildings? Okay, you just pick 2 buildings, 2 zip codes only. So it's a clustering. Any question? Next one. Next one is easy. Every seventh customer entering a shopping mall is asked to select her or his favorite store.
Systemic.
Systematic. You see, seventh, that's it. Okay, systematic every second, every fifth, every 10th. In this case, every 7th. Okay, so the first group is going to be the 7, 14, 21, 28, okay, etc. So because of the every 7th, so this is going to be systematic. Okay, any question? Part C, nursing supervisors are selected using random numbers.
Sampling.
Which one is it?
Random sampling.
It's going to be random sampling. You see, because using the random number. Random numbers. If you use random number, or just a computer to select the nurse supervisors, in that case, you're using random method. Okay, we call it random or random sampling. Any question? The next one, again, is not bad. Every hundredth.
Systematic.
Systematic. You see this term, hundredths. Every hundred is going to be systematic. Okay, this part, there is a second part that we don't have it, so we can ignore it. It's a stratify, but you don't have the second part. Okay, so these are from the first selection that we have. Any question? See, this part is male couriers of a large city are divided into 4 groups according to the gender and according to where they work or ride, and then they call it, it's going to be a stratify. I don't have the other part now. So let's go on. This is from your book. You have one list, a large list of the assignment on this one in your book.
What was that last one, stratified?
Last one, it's going to be a stratify. This is, if you want to get that, let me see if I can. I should, because there is a second part for this one, which is missing. It's a stratify. Let me read you that last part. I should correct this one so that I can have it as well. This is going to be, I read that the last part for you. So that's part E, is a male courier of a large city are divided into 4 groups according to the gender, male or female, and according to whether they walk or ride on their routes. Okay, so then 10 are selected from each group. Okay, 10 are selected from each group and interviewed to determine whether they have been bitten by a dog in a last year. It's a stratify because they divide them into each group and they pick 10 from each. Okay, it's going to be a stratify, but we have more from your book to go. So look at this one. This is, I think, section 1.5 of your book that we want to do it. We get quite a lot. So what we'd like to do is we want to identify each the type. So random, systematic, convenience, stratify, or cluster. Okay. So in your book, we go with the five different case. And for the test, you should expect to have those, okay, those 5 1 to go through it. Okay, so let's try to see if we can do it. The first one,
Is that
And-
convenience?
yes, an NBC television news reporter gets a reaction, yes, by polling people as they pass the front of his studio. Okay, it's convenience because, you know, it's a lazy one if you like. So this is the first one, convenience. Okay, going to the next one to get that second one. So what's the second one? The Dutchess County Commissioner of Jurors obtain a list of 42,763 car owners and construct a poll of jurors by selecting every hundreds.
Systematic?
It's systematic. Systematic because you're picking, you know, every hundreds on the list, you know, the first person, 100, 200, 300, 400. So that's going to be, that is systematic. Systematic, okay, to go on. Any question? So ready for the next one. So it's going to expand. The next one, in the Gallup poll of 1,059 adults, the interview subjects were selected by using a computer to randomly generate it.
Sampling?
It's going to be random sampling. It's a random sampling because they use, you see, they use computer to randomly generate telephone numbers. So since we're using a random device, it's a random sampling. Okay, random sampling. It's like, you know, when they ask you for the jury duty. Any question? Next one, a little bit tricky. Let's see for the next one, a General Motor. So let's see what they do. A General Motors researcher has partitioned all registered cars into categories of subcompact, compact, mid-size, intermediate, and full size. She is surveying 200 car owners from each category.
Just
This is a stratified
Stratified?
sample.
Stratify, yes, stratify. You say stratify and canceling and clustering is tricky, but remember, she was 200 from each category. So what you have is you pick some people from, or some from each category, means at the end, you have a very nice sample, and that would be the representative of every types or every person. Okay, any question? So in the case of a stratify, you must have a very nice, you know, sample that include every types or every person in the zip codes. So that's a stratify. Number 13. Motivated by a student who died from drinking, the college constructs a study of a student drinking by randomly selected 10 different classes and interviewing everybody in the class. They want to get the information. They randomly select 10 classes and they
Is it a cluster?
Stratified?
yeah, that's clustering. That's clustering because you know that there are more than 10 classes in the college. They just pick 10 classes. Okay, they pick only calculus classes, for example, or the statistic classes only. So again, it's clustering. It's clustering because there are other people in the college. You didn't ask them. Okay, you just asked the people on that 10 classes. So it's just a specific one, so it's a clustering. Any question? The first one, the next one, 14, we can do this one too, not bad. 14, marketing executive for the General Motors. Find its public relations department has just printed envelope with the names and address of all COVID owners. She wants to do a pilot test of new marketing strategies, so she thoroughly mixed all the envelopes in a bin, then obtains a sample group by pulling 50 out of those envelopes.
Is that
Which one?
random?
It's a random. Because she got the names, she mixed them together. Okay, she mixed the envelopes together and she picks some. So
Yeah.
that's going to be random sampling. Okay, question?
Can't it be convenient sampling as well?
No, because,
She's
It's-
randomly like
yeah,
picking
she
them out.
randomly picks some. You see, because she thoroughly mixed all the envelopes, then obtains a sample by 50 of those. No, even, a kind of a random device is used, that you mix them together. That's going to be one. Okay. At least, she prepared the envelopes and you put them together. So random is better. Okay, number 15, not bad. The author was an observer at the police, checkpoint at which every fifth
Systematic.
every fifth driver stopped. You see, systematic is the one, you pick. Every fifth means the fifth, the 10th, the 15th, okay, the 20th, etc. So it's a systematically you pick those people, and just every fifth, as soon as you get the fifth, it's systematic. Question? So go on, 16. CNN is planning an exit poll in which 100 polling stations will be randomly selected and all the voters would be interviewed as they leave the premises. CNN,
Sampling.
which one?
Random.
No,
Is this stratified?
Oh,
no,
this is convenience.
no. No, just think about it, you see, we have many polling stations. So what they did, they only pick
Cluster?
It's cluster.
Because there's
See.
because there's more than 100 polling stations.
Yeah, that's it. Yes. So they just pick 100 and then they pick 100 and interview everybody in that. So it's clustering. It's clustering because there are more than 100. Okay. There are more than 100
Why is it not stratified?
because there are more than 100 polling stations.
I agree. There might be 1,000 and we selected 100 of them. And now I'm going to interview all the people with those 100. Doesn't that fit into the category of divide your population, select a stratum from each sample set,
No,
and then use, no?
No, because you have to, okay, so what you're going to do, you have to divide that population into that 100 polling station, the full population for the stratify. You see, that's
Okay.
that's a difference.
I don't quite understand, but we can move on.
You want me to help
okay.
explain it to him? A little bit?
Yes.
Okay, so basically saying for stratified, you're including the whole entire population. So if you use this example, you would be dividing the 100 polling stations into subpopulations versus for cluster, the 100 polling stations is a part of the population, part of the bigger, or right. So like you were saying, if there would be 1,000 stations, this only includes 100. So that's why this example is cluster. Does that make sense?
So it would have to be, what you're claiming is that all 1,000 polling stations would have to be included for this to be stratified?
Yeah, yeah, if it was saying it, yeah,
Yeah, because because you just you want to carry out about the population. So for the stratify, you see the job is stratify. We divide the population into a strata, if you like. So in this case, they just pick 100. So the leftover. You see, stratify at the end, you must have a representative of everybody in your population. So it's a CNN. So in that case, the population is the full nation, if you like. Okay, or if it's going to be one state, it's going to be everybody lives in that state. But they just pick 100. So that would be classed there, the way they do it. Okay, so that's number 16. Maybe that's the reason I marked it. So let's go on. How about 17? Economist is studying the effect of education on salary and conduct a survey of 150 randomly selected workers from each of these categories. The people, okay, categories are less than the highest school degree, highest school degree, more than the highest school degrees. Okay, so they want to know what's going to be, the actual case that you're going to have. So what they do, they survey 150 randomly selected workers from each of those categories that we have.
Stratified.
It's a stratify.
Yeah.
It's a stratify because this is what we have, okay, for those population that we have. So all the cases, for the degrees are there. So it's a stratify. Okay, because they pick 150 workers from each of these. So it's a stratify. Okay, let's go on. It's 18. Statistics, students obtains height, weight data by interviewing family members.
Isn't that convenience?
Yeah, it's convenience. It's a lazy one. Okay, it's convenience. You're just using your family members. Okay. Any question? Let's go to the next one. If you don't have any question, number 19, Johns Hopkins University. Johns Hopkins. This is the one that I think I talk about it, but or not. A Johns Hopkins University researcher surveys all cardiac patients. Okay, all cardiac patients in each of the 30 randomly selected, selected hospitals.
Stratified.
In this one is going to be,
Stratified.
seems to be stratified or cluster.
In cluster.
It's cluster.
So there's definitely more than 30 hospitals, right?
That's it, yes. Yes, because they talk about hospitals. Okay, they pick only, yes, they pick 30 hospitals and they interview everyone. So there are more than 30 hospitals. Okay, so Johns Hopkins University would be divided into hospitals and they pick only 30 hospitals out of those and they interview everybody. So that's clustering. Okay, number 20, MTV. A marketing expert for MTV is planning a survey in which 500 people will be randomly selected from each age group, 10 to 19, 20 to 29, etc.
Is it stratified?
It's a stratified. It's a stratified because you're covering, everybody that you get it. Okay, so this is going to be, it's a very good, examples that you have. The one in your book is a little bit different in that new edition, but you got the idea really to get the result. And we give you one question on this one, you have a similar one, your practice quiz. We give you one question, it's going to be 5 parts. And you just tell us Just be careful about that clustering and stratify. Make sure you get this one right. Otherwise, the rest is going to be all right. Okay, so that is a sampling method. Any question? Okay, so this is going to be our sampling method. I can give a short break if you like. And then we come back. We have only one more section to cover from chapter 1. And that section is the things that's going on in everyday life now. You see, this is sampling method. In future, if you want to do something scientifically in your discipline, you are going to do, we call it the statistical studies. That is statistical study is going to be divided into 2 parts. The first part is you are going to be sent somewhere, you are sit, observe, something is going on, you observe and you make a note. You make a note maybe for days to find out if there is something common is going on. Something is going on, can you find any association with, with what's going on in that observation that you have? So it's called observational studies. The other one is sometimes we have to design something, and this is what we do, whatever discipline you are. In order to carry that statistical study, you may have to design something, some experiment, and going on. For example, these things about vaccination, the vaccines that they introduce before they go to the FDA and ask for the, CDC, they ask for the ratification or confirmation. So what they do, they have to produce a data. So in order to do that data, they are going to design an experiment. Design an experiment is they are going to select something like 10,000 people, and they're going to apply the vaccine. The way they do it, we divide them into 2 groups. The first group would be given the real vaccine. The other group would be given something else, a vitamin or something. And then they wait to see what's going to be the result. This type of work is going to be called experimental one. So it's the actual one that we're going to do in future. But in this case, we just give you a definition. Okay, we give it 10 minutes. It's 11:20 almost. 11:30, we come back and we take care of it, and then we'll be able to give you a little bit of chapter 2 as well. Okay, see you in 10 minutes. So we are going to collect our information from those 2 different types, 2 different sources, if you like. So in a statistic or a statistical study, we obtain the data, from 2 sources. Okay, 2 sources. Sources are going to be observational studied. Okay, this is one source, observational studies, and the other one is going to be designing an experiment. Okay, that's going to be design of experiment. Or we call it experimental one. Okay, experimental method. Second one is we do it in most disciplines. Observational one, you stop, you observe, and you make a note. You are going to make a, collect your information, you make a report, and then you may study that report and to see what is going to be, what is going to be maybe probably the cause of that, whatever you are looking for, and then you may have to do something about it. Okay, so just what is going to be observational one? Observational studies. We observe and we make a note. Okay, we observe and measure. We observe and measure a specific characteristic of the population, okay, or sample. Specific characteristic depends what you are looking for. But you're not going to do anything. You just observe and you make a note. Maybe you are going to be an observer for an election. You just observe the election, okay? But you're not going to change, the people vote. So make sure that you are not going to take any action. But we don't, okay? We don't take any action. Attempt to change anything. Attempt to modify the result or change. Okay, the subjects. Subjects being studied. Okay, the expression that they use, they say in observational one, you're looking for association. This is the expression, if you listen to the news, when different experts, they're talking about the coronavirus, they usually use this expression nowadays. So they say observational studies reveal, it's their expression, reveal only. Expression is association. So you observe to see what's going to be common. You check this one. Okay, there are the three different type of observations that we do. Sometimes you are going to do your observational studies by going in the past and collecting the information. Okay, so collecting information that's already been published, so you can go and make a note. If you do this type of studies, they say that your study is retrospective. Retro means belongs to the past. But sometimes you are going to observe a situation now and getting into the future. So you want to know what's going on, to this, this population, to the coronavirus, for the years to come, okay, in 4 years times. So yes, you start your study now, but you have to wait to get to the 4th year and then make a report. In that case, we say your study is prospective. Prospective, the future, but sometimes you pick a special time and you just collect the information, mostly present time. It's going to be cross-sectional. So you must know these expressions because the situation would be given. You have to identify for us which one is it. Okay, so types of observational study. Okay. So the first one is called the cross-sectional. Okay, cross-sectional study. It's going to be a study that related to a present time. Okay, if you like it, this is going to be related to the present time. It's a specific time. So in this case, you are going to collect the information, data. Okay, data are observed in a specific time. Observed measured, object measured and collected at one time, 1 point. Okay, at 1 point. 1 point in time. That's a cross-sectional one, or present time, or at present time. That's cross-sectional. When talk about unemployment rate, is cross-sectional studied. Because you know, you just check the unemployment day to day to see what will happen, you know, at one specific time, you check that one. So that would be cross-sectional one. Okay, any question? If your information belongs to the past, retrospective. Retro means past. Okay, so what is a retro? Retrospective. Retrospective study. This is going to be past time. Okay, you collect the data from the past. Data are collected. Data are collected from the past. Okay, from the past by going back, you know, you go to the library and just find by going back in time. So your stat is going to be retrospective. Get information from the past. And if you intend, you know, to collect the information in future, that would be prospective. Okay, so prospective, that is going to be, okay, prospective study. Prospective study, this is going to be future. Okay, that's it. In the future time. So you are going to collect the information in future. So data, if you like, data are going to be collected in the future, in the future. You know, the future from the, you know, from a group or sharing something, you know. Okay, so again, you know, the various examples, we are going to have a group of examples, but those watching or observing what's going on in the case of the election, for example, is going to be a kind of observational studies that we're going to have. Okay, you just observe and you make a note. And we have a couple of other cases. We are going to check it in a minute. Okay, very similar to your book. So let me talk about that experimental one at the same time. Then we go and give you those, we check those list of the examples. Okay, any question? So, you know, you observe and you make a note to see what's going on. This is going to be done in various form. Again, most of the times related to the health. So, you know, they check to see what's, you know, what's in a society. Sometimes something's going wrong. So they observe to see for the time being, to see what seems to be causing this type of, you know, those type of phenomena, if you like. from your observation. Then you may go and design something and go for it. Okay, so that's going to be observational one. Let me just give you a couple of words about that experimental one. Then we give you example. This next one is much more popular because it's the one that we're going to do it in future. So experimental design, they call it, the second method. Okay, that's going to be, you have to design an experiment to do the job. You know, if you're measuring physics, chemistry, or any engineering discipline, this is the way we're going to do it. You have, you know, you want to find out what is going to be, you know, a specific reaction or the result of the formula. So you design the experiment to check it. So that would be experimental design, they call it, or experimental method. So you have to apply something, you have to design something. It's not like observational, but it takes more time, it needs money. So in this case, in an experimental study, you have to spend time and money. What we do, we apply some treatment, some experiment, you know, they talk about some specific example, and then we proceed to get the result. Then, okay, then they proceed to observe. Okay, observe its result, its effects. Result on effect on the subject. In this case, the expression that they use, they say they are looking for the causation when they use experimental work. They want to know what's going to be the cause of the, you know, this change, if you like. So in this case, the expression is we try to establish or to establish causation. That's the expression. If you want to get the causation, you go for the experimental one. If you're just interested in association of something going on, in that case, you are going to go for the observational one. Most of the, again, if you want to try a specific drug, vaccines, you have to design the experiment. Okay, so this is just for example, you know, a new drug for lowering your cholesterol, Lipitor. So if you want to try this one, a clinical trial of the drug. Good one. Of the drug Lipitor. It's the one that lowering your cholesterol. Lipitor is an example. Of an experiment or experimental one that we're going to. Okay, now the way they do the experimental one, or if you want to design it in future, there are some rules that you have to follow if you want to design it. And the way they do it, they divide that specific population. They pick, you pick 100 people and you want to check, what's going to be the cause of the Lipitor, for example, to lowering the cholesterol. So you pick 100 people, they usually divide it in two parts, 50-50. For the 50 of those population, they give them the real Lipitor. And for the other 50, they give you some other liquid. Okay, but not the Lipitor, if you like. Or some vitamins, vitamin D, etc. So then they wait. They wait to see what's going to be, what's going to be the result. You have to observe both groups, okay, to get the result, like the vaccines. So there are some rules that you have to follow. I just write those rules so that you have you see the expressions in case in future you want to see it. So these rules are going to be called principles. Okay, again, you may heard about this during the news. Principle of experimental design, experimental design. They usually go with 3 rules. The rules, they call it controlling. The first one is control. Control. The second one is, they call it randomization. Okay, randomization. And the second rule that you have to follow is a replication. Okay, a replication. We usually use these 3 expressions for the designing the experiment: control, randomizations, and replication that you can have. So as I told you, we divide the people, the sample of the subjects that we have. We divide them into 2 groups. So the controlling one is going to be, you just make sure that when you want to pick the groups, then you are going to observe them, make sure that they are applying that drag, or they're following the rules, if you like. And it's going to be kind of controlling. Randomization means you got to be careful. You got to pick the people randomly, of course, and then make sure that you have a sample which is a representative again of the society. So if you want to check a vaccine, so you have to pick the people from different social background, different lifestyles, to make sure that your results can be a valid one. And you have to pick them randomly, briefly. You can read more about these ideas in your book. And the replication is going to be, you see, when you have these 2 groups, so you may see effect of the Lipitor on one group, if you like. The replication means you should have enough people. It's a repetition, if you like. You must have enough people, in one group to see this type of replications that you're going to have. So, for example, sometimes, some people, if you feel sick, but as soon as you get to your doctor office or the physician, you feel okay, you feel all right. So sometimes, it would have some kind of psychological effect. So you must be careful that this replication is going to be something to do the Lipitor, if you like, not that placebo, they call it. The placebo is going to be, they haven't got the vaccine, but psychologically they feel all right because they think that they have it. So there are some arguments, you can read this, in your book if you like to see. But these are the 3 expressions that you're going to have when using the designing of the experiment. So you may have to do it in future. So you can read more from this in your book. But the way we are going to ask you the question, we give you 2 questions on this one. One of them is you have to tell us the different types of the observational studies. You have 1 set of problems in your book, and the other one is we give you the study, and you are going to tell us whether it's observational one or the experiment. It's very easy to answer this question because in the case of the experimental one, they have to explain the procedure. As soon as they explain it, you find out that they are doing some experiment. Especially they explain that they divide it into 2 groups. They give something to the first group, the other one to the other group. So then you realize it's not difficult to identify really. Okay, so I'm going to go to the it must be in worksheet number 2. I bring it up so that you make sure that you know how to handle this type of problems, and then we are done with this basic, okay, basic part that we have. So let me bring back that worksheet for you. Must be worksheet number 2. Okay, this is going to be the one that I already posted for you. Again, it is in your book. You may have a little bit different one if you do it online, but that, you know, you will get the idea, and maybe we are going to question you. Okay, so what's the question? The question is, we would like you to tell us this experiment that we have 1, 2, 3, 4. Tell us which one is it. These are statistical studies. Is it observational one, or can you say it? You know, let me just, I didn't share it, I think. So that's a worksheet number 2 that we already have it, got it posted. Okay, can you say it now? Okay, so what we'd like to do is read this carefully and tell us which type of studies do we have. Is it observational one, or is it an experiment? Observational one, you observe and you make a note. But experimental one, you have to design an experiment. You have to apply something, get that some treatment to be able, you know, to take care of it, to get this number. Okay, the first one is like the one that I did. Patients are given Lipitor to determine whether this drug has the effect of lowering high levels of cholesterol. Which one is it? Experiment. It's experiment. It's experimental studies because you apply it. You know, you got the people, you are going to give them Lipitor and wait to see what's going to be the effect. Okay, so that's going to be experimental one. Any question? The next one. More controversy arose over the study of patients with syphilis, okay, who were not given a treatment that could have cured them. Their health was followed for years after they were found to have it.
Is it
Observational?
It's observational. Because you're just reading this as a report, they observe, you see, they've been under observation for years to see whether, you know, you have. Okay, it's going to be observational. Number 3, the Dutchess County Bureau of Weights and Measures randomly selects gas stations, obtains 1 gallon of gas for each pump. You know that when you go to the gas station, to the pump, you will see that they give you there is a note that the last time that, you know, they check this one, that they make sure that when they say 1 gallon, you really get 1 gallon of the gas. Okay, that's going to be they're just looking for the consumer fraud, if you like. Okay, any suggestion? They go and you check it.
experimental?
Any other suggestion? It's not going to be experimental because what they do, they just check it. They are not going to apply any, you know, they don't try to change it. You see, they observe. Yes, they measure and observe and they make a method. You're not going to apply any, you don't design any experiment to get this one. So it's a, you know, the guy or the bureau, they are just responsible for observing. They're observing whether this is right or not, this is correct or not. Okay, if it's not going to be one, they are going to report it. So they just checking for this kind of association. So it's going to be observational studies. Okay, because you don't, the guy who's coming is not going to do anything. You just observe and make a note. Okay, so it's going to be observational studies. Any question? Number 4. cruise ship passengers are given magnetic bracelets which they agree to wear in attempt to eliminate or diminish the effects of the motion sickness.
Observational.
Let's see if you are wrong. No, why it's observational? Yes, Kevin, you are right. It's experimental. You see, it's experimental, remember, because they apply something. You see, they give the passenger, look at this one. The passengers are given magnetic, those magnetic bracelets that you get. So they apply something to see what's going to be the result. You see, they apply this one, and the people would be divided into two groups, at the end. Some people will feel better, or some people will not. So that would be experimental one, because you're applying the device to get the result. Any question? So if you apply, you design the experiment, if you like, to get the result, it's exactly, it's going to be your design. Okay, any question? Okay, how about this? This must be straightforward. These are observational studies. When you get observational studies, we talk about it. You may observe something from the past. So your study is retrospective. You may observe something that take you into the future. So that's going to be your study is prospective one. But you observe just once in a time, it's going to be cross-sectional one. Okay, so that's going to be one. I'm going to change this time. You see, that's from the previous edition. In your book, probably you are going to have something different. This 2010. Okay, you may call it 2025. This is from the kind of second edition. Okay, it's 2025. Okay, so that's it. Cross section something at one time in a maybe present time. Retro belongs to the past. Pro belong to the future. Okay, already the first one, number 5. A researcher from New York University School of Medicine obtained data about the head injuries by examining the hospital records from the past 5 years.
Retrospective.
It's going to be retrospective. It's retro because you have the past. Okay, past would be retrospective. Okay, any question? Remember, I changed this one to 225. So a researcher from Mount Sinai Hospital, New York City,
Prospective.
is prospective. Obtained the data by following to the year 2025. Okay, so I changed it, so that we get prospective. Prospective because, you start with, 9/11, and then you go to get to the 2025. Prospective. Okay, any question? Next, U.S. Labor Department obtains current unemployment date by polling 50,000 people this month.
Cross-sectional.
Cross-sectional.
Cross-sectional because it's present time. It's present time, so it is cross-sectional studies. Okay, and lottery winners. And economics collects data by interviewing people who won the lottery between 1995 and 2000.
Retrospective.
Is retrospective because this is past time. Okay, so the past time is going to be retrospective. Present time is going to be cross-sectional. Future time is going to be prospective. So it's not bad to get these things. Okay, any question? So I would like you to give you different formats. Okay, if you like, this is going to be the one. Look at this number 17. Number 17, identify whether it's observational or it is experimental. That's better than the one that you did. Okay, are you ready? The first one, part 1. Subjects were randomly assigned to 2 groups. One group was given an herb and the other group a placebo. After 6 months, the number of the respiratory tract infections each group had were compared.
It's experimental.
Yeah, that's experimental. That's experimental because nicely it's explained. Okay, you design an experiment to get result. So that is part 1 is experimental one because they just nicely, explain the procedure for you. Any question? Part B. A researcher stood at a busy intersection to see if the color of automobile that a person drives is related to the running red lights.
Observation.
It's observation. It's observational because you are not going to apply anything. You see, you just wait and you observe and you make a note. Okay, it's observational studies. Any question? Part C. Part C, a researcher finds that people who are more hostile have higher total cholesterol levels than those who are not.
Is it observation?
Yes, it's observational. Because you just observe, you make a note. So that would be observational study. So part C is observational. Question. Part D, subjects are randomly assigned to 4 groups. Each group is placed on one of the 4 special diets, a low-fat, high-fish diet, combination of the low, that. After 6 months, the blood pressures of each groups are compared to see if the diet has any effect on the blood pressure.
Experimental.
Is experimental. See, nicely you explain, the full experiment that you have to design. Okay, so that's give you an idea of how we're going to apply these. Okay, and you should get the idea of what's going on. Okay, so this is going to be chapter 1. That's all we cover from chapter 1. Okay, so read it carefully. Just make sure you have no difficulty, and you have a similar problem in your book. And when I post your practice quiz number 1, you will see this type of ideas. Okay, any question? We're done with chapter 1. Okay, the basic. There are some other, you can read your book if you like a more essay type explanation of these ideas. But what is going to be the next step? Okay, so what we did, we put together the information that we are going to collect. Now we have the idea and designing our experiment that we have. So the next step is going to be, let's do it. Okay, the next step is going to be, now you know the type of information that you need. So the question is going to be how we're going to collect the information that we talk about it. You see, if you want to do a statistical studies, remember we talk about a population. You pick a population, the population is very large. So what we do, we are going to select a sample. So we select a sample and we already talk about the sampling methods. So you have the bunch of numbers. The next question is going to be how we're going to do, what are we going to do with these numbers? So you have to organize it for us. Remember, we say that statistics is the science of collecting the information. Now you know how to collect. Then the next step is going to be designing it nicely, put them together nicely so that we'll be able to find what's going on. So in this chapter, we go to chapter 2, and we take a couple of sections from this one. And we hope your quiz would be given to you between, for the chapter 1 and chapter 2. But in chapter 2, we're just collecting. Officially, we go just a few sections. So this is going to be 2.1. 2.1, a little bit more operation that we're going to do. And we are going to give how we're going to organize. Okay, how we're going to organizing. How we're going to organizing data. The information that we collect. Remember, the information would be divided in two groups, categorical one and qualitative and quantitative one. But what we are going to do is we are going to put them together. The method that we're going to use is called grouping method or grouped method. So in order to get a good idea of what's going on, okay, in order to obtain, if you like, to obtain information, okay, information from a given set of numbers or set of information from a given set of data or data, we are going to put them together. Okay, so one can organize it. One can organize the data value. Okay, data values. The method that we're going to use is called grouping method, using okay, grouping method. Now, how are we going to do it? You see, I've already posted this one for you. It's probably worksheet number 3. Look at this one. This is going to be your job in this section. So we collect this information. What is this information? This information is related to the patients. You see some cancer patients after a while, sometimes after 2 months, 3 months, 1 year, the tumors may reoccur again. Okay, so we just collect information from 42 patients, cancer patients, and we check the time, the time where the tumors reoccur. Okay, that's going to be what. These times are in month. So we collect it and we write it down. You see, we get the 19 months, 18 months, 17, etc. So what we would like to do is we'd like to, you see, as these would be given to you, you won't get a very nice idea of what's going on. But if you group them together, we group them together as a specific table, then you may be able to get the information. For example, you want to know what's the chance. What the chance a patient tumors would recur, okay, after 48 months, 35 months. Okay, so that's the purpose of put these together. Method of the grouping that we are going to have, we are going to group this information into different categories, different classes, if you like. You see, to just show you that what would happen at the end. You see, this is going to be what would happen at the end. Okay, I'll just explain this and I do it next time for you. Okay, just get the idea. This is going to be called grouping method, the organization that we're going to have. The way we are going to organize it, we are going to check the numbers in different group, different classifications. You see 1, 2, 3, 4, 5. We pick 5 classes or 5 categories. It depends. These are numbers, so I have to name the group by the numbers. So in the group 1, I'm going to put all the numbers between 1 and 12. So these are going to be the number of the patient that they get the cancer reoccur between 1 month and 12 months. Okay, that's going to be the class 1. Then I'll go with you see the difference is 12. So it's going to be 1, 13, 25, 37, 49. So I pick these classes. So these are going to be, the first column is going to be called classes. So the classes is going to be categories, that we are going to consider. We go with the numbers. Some people, they like the numbers going to 10, 20, 30, 40, 50, 60. But we are going to design it and we're going to tell you how we're going to do it in this format. Okay, so the first column is going to be classes, the categories, the name that you put them together. The second column would be called frequency. Frequency is the number of the repetition. So you go to that data set that we talk about it, and you check to see how many numbers are going to be between 1 and 12. Okay, how many patients do you have that the tumors reoccur between 1 and 12. So we are going to count them. For example, you see this is the one that we have. If you count the numbers between 1 and 12, you see the 1 and 12, you get the, for example, you get the one over here. Okay, that's going to be 1, 2, 1, 2, 1, 2, 3, 4, 4, 5, okay, 5, and the 6. So you find out that the 6 patients would have this between 1 and 6. So we put the 6 here, and then we get the other ones. So the first expression or terminology is going to be classes. It's going to be the category that we're going to consider. We're going to tell you how we're going to check these. The first number that goes to one class is called lower limits or lower cut. This is going to be called upper cut, okay, upper limits. So the lower limit is 1. So 1, 13, 25, 37, 49 is going to be lower class limits. These are going to be upper class limits. We are going to tell you how we're going to do it. Just get to know the expressions. Frequency, I talk about it. It's a number of the observation, number of the values between each class. So we are going to find out all of them and we add them together. Relative frequency is going to be percent. So for each class, it's going to be percentage of the number of the patients, 6, divided by the total number of the patient, 42. So we write it down in percent, and in future, this would be probability. So for example, when we organize this one, we just have a look to see the highest number that we got, something like 28% is here. So we say that the chance that the tumor of the patient would recur between 37 months and the 48 months is going to be something like 28%. So if you pick one patient out, there is 12% chance that the cancer of that person would recur between 25 and the 36 months. Okay, so these are going to be the probabilities, if you like, in future. We call it frequency probability, and this is going to be just the frequency. And there are some other expressions that we put over here. At the midpoint is going to be the average of these classes. These are going to be used in future. Okay, and these expression together. So that's just an idea, but I'll do it next time for you at the next class. Make sure to get this one ready. Okay, make a copy of this one or in your lecture notes, just bring it here, okay, because we are going to construct this table eventually. And we do this table, this is for the numerical one, and then there is going to be the second part for the categorical one. Okay, it takes just one full lecture to do it. It's not difficult, it's easy, it takes times. And you are going to do one of them for us on the next quiz and the next test. Of course, we can do it with different softwares, but we want to do it right now just to check it at the preliminary levels. Okay, that's it. So we are done with chapter 1. You should be able to do the problems on the chapter 1 now. And then we do the chapter 2, 3 sections next week, and then we give it a quiz. That's it. Do we have to submit the worksheet? No, the worksheet is the one that we do together. That will help you.
Thank you, Professor.
The only one that you are going to submit for extra point for future is your take-home quizzes. For each quiz and the test, we give you a take-home one. We may give you also one from this quiz. But I post the practice quiz, so the practice quiz is the one we do together. The take-home quiz is for extra points, 2 points for each. Okay, have a good one and take care. See you next week. Get to chapter 1.
I have a
Thank you,
question.
Professor.
Yes.
So on the My Math Lab, there's certain homework assignments that are on there. We do have to complete those by the due date. Is that correct?
That's it. Yeah.
Okay.
So
I
that
just
would
wanted
be
to make
your
sure.
that would be your 40 points. If if you miss the due date, you
Mhm.
just request it, then I give you an extension.
And there's no penalty for how many times you like try to go back and correct wrong answers or anything like that?
No, I don't think so.
Okay, perfect. I just want to make
Assumption.
sure.
Yeah, we just want to do it really. That's why. If you miss
Okay.
the deadline, just let me know. I extend it for you.
Perfect. Thank you.
Bye bye. Any more question? That's it. Have a good one. If you need help, we talk about it. You can email me. Then we can arrange something on Zoom, when we get to know it. Okay, have a good one. Take care.
Bye-bye.
Okay, bye-bye. Yes, I'll be Elizabeth. Yes, I can stay if you have any question. Okay, any question?
How do you get to My Math Lab?
To get to the MyLab,
Yeah.
I posted a link for you. Okay, if you go to the canvas.
Is
Okay.
the My Lab statistics access?
Yeah. If you collect that, then that take you to the math lab. Then you have to, you have to
Create an account?
create account. Yeah. You have
Okay.
to create account, then that take you to the problems. It's good that give you electronic version of the book, and you can do those assignments from the math lab to get your 40 points. You need it for even if you have a book, you need that one for your assignments.
When's the first assignment due?
I think it should be due in 20 weeks times after today quiz day.
Oh, after the quiz day, so it's 16th?
Yeah, it's gonna be on the quiz. I think it's 20, the first
Okay.
one. But it's no big deal. If you miss the deadline, just then you request an extension. I give you the extension to do it. So
Right.
those 2 days are generated by the computer, if you like.
Thank you, Professor. I'll see you on Tuesday.
Okay, bye-bye.
It is also available on the Palomar bookstore, right?
Yeah, it's gonna be, it should be.
Okay.
Should be. If you have a grant or financial aid, you have to buy it through the bookstore. So otherwise you can do it, you can do it directly online. That's one. Okay, more question?
I don't have the book yet, so I'm just making sure we don't have anything due during the weekend anytime soon.
No. If you don't have the book, you better study the lecture notes.
Yes.
Okay, and review this worksheet that we have, because these are more or less like the problems that you have to do so far. You'll be fine. You'll be fine, that's fine.
That was all. Thank you.
Okay.
Okay.
Okay, that's it. Anything, you just email me. And have a good one. Take care. Bye.